Welcome to my Primary Maths and Sats Help videos. This video is all about place value and how we use it to read and write numbers. So what is place value? Well, place value is what we use to determine the value of the digits in any number. Our number system only uses the digits 0 to 9, so to represent any number bigger than 9 we have to change the position of the digits. So if we look at these examples, all of these numbers contain the digits 2 and 0, but the value of the 2 is very different in each case because it has a different position or place. So here we have our 0 and 2 numbers written out again, but this time showing which columns each digit is in and therefore their value. This is what we call the place value scale, and it's based upon the powers of 10, so 10, 100, 1,000 and so on. And this scale never changes, and it's really important to learn the order of the columns, starting with the decimal point. So immediately to the left of this we have our units, or some people call it the ones column, then your tens, your hundreds, your thousands, your 10,000s, your 100,000s, and then millions, and so on. And then to the right of the decimal point we have tenths, hundredths, thousandths, and so on. Now all the digits to the left of the decimal point represent whole numbers, and all of the ones to the right represent digits that have a value of less than 1. So 1 is the smallest possible whole number that you can have, and that would be in the units column. So the first number represents, if you look at the column headings, 2 hundredths. The next one, 2 tenths. The next one is 2 units, or ones. We simply call that 2. The next one, 200, because the 2 is in the hundreds column. And the last one, 2000, because the 2 is in the thousands column. Now, if the 2 was in the tens column, that would represent 2 tens, but we would also call that 20. So let's see how we can use place value to read whole numbers. So if we look at the first example and put it on our place value scale, we can see that this number has got 3 in the hundreds column, 2 in the tens column, which represents 20, and 8 in the units column. So we read this number as 328. This number's got 5 in the thousands column, 7 in the hundreds column, 8 in the tens column, which is the same as 80, and 4 units. So we read it as 5,784. And both these examples show that we actually read the tens and the units together. Here we've got 700, then we've got one lot of 10 and one 5, which together make 15. So together that number reads as 715. And this one we've got 4,312. And here are some for you to do yourself. If you'd like to, you may want to pause the video at this point. So the first one is 211, then 6,549, and the last one, 9,302. Note that these are all whole numbers because the digits are all to the left of the decimal point. We don't write whole numbers with a decimal point because there are no digits after it, but be aware that it's still there and its position never changes. So let's look at some slightly bigger numbers. So here we can see that we've got digits in our thousands column and our 10,000s column. Now the trick with these bigger numbers is to group the thousands together. We can see there are 3 columns here, 100,000 on the left, 10,000 and 1,000. So if we look at the number we've got and just group together the thousands, we can see that we've got 34,000 there plus 267. And that's how we would read the number. Let's do the same for this one. If we group our thousands together, straight away we can see that we've got 95,000 there and 401. Here we've got an even bigger number. Let's group the thousands again, and we can read that as 234,698. Here are some for you to do on your own. If you'd like to, you may again want to pause the video to give you time to do them. So the first one, if we group the thousands again, 47,615. Here we've got 903,813. Here 114,507. And the last one, 80,654. Note that there are zeros in various places in these numbers, and they're vital because they represent columns where there are no digits, but we need to have them there to make sure that all the digits are in their columns, and we call those zeros placeholders. Just as we use place value to read whole numbers, we can use it to help us to write whole numbers. So sometimes we're given numbers written as words and we're asked to write them as digits. So again, if we think of grouping our thousands, that is really, really useful. So the first one, we've got 4,504. So we need a 4 in the thousands column, 5 in the hundreds column, and then 4 units. Notice we've got 0 in the tens column, that's our placeholder. This one we've got 71,327. Let's group the thousands together in the words. 71 of them. So think where the 71,000 is going to go. You can see there, and then the 327. This one, 105,902. Got 105,000. Where's that going to go? You can see it grouped there. This one, 767,000. Sounds a real mouthful, but again, if we group it together, it makes it really easy. 767,000, then 459. We can see there's our 767,000. Here 11,803. Here 431,692. 431,000. Let's think where that would go. And the last one, again, I've grouped the thousands together. So here we've got 586,000, so we know where that's going to go. We just need to add the 3 million, the 400 and the 23. And that's what that would look like. Notice again that we need the placeholders where we don't have any digits represented. Sometimes we are asked to give the value of particular digits in different numbers, and again, this is where place value can help us. So we might be given a number like this and asked to give the value of the 5. So if we use our place value headings again, we can see that the 5 is in the 10,000s column, so 5 lots of 10,000 is 50,000. So the value of that digit is 50,000. Here we're asked to give the value of the 2. You can see that it's in the tens column, so it's 2 lots of 10, which is the same as 20. Here again, we've been asked to give the value of the 2, but this time it's in a very different column. It's in the thousands column, so this digit represents 2000. So see if you can do these next ones yourself. So here we've been asked to give the value of the 6. It's in the hundred thousands column, so its value is 600,000. Here we need to give the value of the 5. It's in the units column, so the value is simply 5. And the last one, the value of the 1 is in the millions column, so its value is 1 million. Place value is also really useful when we need to partition or split numbers up into different parts. This is particularly useful when we're doing addition and multiplication calculations. So if we look at the first number, we've got the number 25, which we can see is made up of 2 lots of 10, which is the same as 20 plus 5. This number we've got is 345, is made up of 300 plus 4 tens, which is 40 plus 5. This one, 107, we've got 0 tens, but we've got 1 in the hundreds column, so 107. Here we have 8 in the thousands column, so 8,000 plus 600 plus 5 tens, which is the same as 50 plus 3. Here we now have a 9 in the 10,000s column, so that's the same as 90,000 plus 1,000 plus 700 plus 20 plus 4. And the last one, now we've got a few more thousands. We've got 600,000 plus 9 lots of 10,000, which is 90,000 plus 5,000 plus 700 plus 8 lots of 10, which is the same as 80 plus 2. Having an understanding of place value is also really useful when we're doing mental addition and subtraction. So we might, for example, be asked to say, what must we add to the first number to make the second? So here's an example. If I put these numbers on the place value scale, we can see straight away that there's a difference in the tens column. All the other digits are identical, so we've added on 2 tens, which is the same as 20. So we're looking at which column is being affected. Another example. Here, there's only a difference in the thousands column, so we've added on 2 more 1,000. Here, the difference is clearly in the 10,000s column, so we've added on 7 lots of 10,000, which is the same as adding on 70,000. We might be asked to do it the other way round then. So, for example, what must we subtract from the first number to make the second? So again, we're going to use our place value scale because it makes it really clear. What have we subtracted? You can see that there's only a difference in the tens column. We've subtracted 6 lots of tens, which is the same as 60. Here the difference is in the thousands column, so we've subtracted 6,000. And the last one, the difference here is in the 100,000s column, so we've subtracted 400,000. So I've given you a practice page here with whole numbers in case you find that useful. So can you read and write the following numbers? And I've put the place value scale headings at the top of the page for you to use if that's useful. So questions 1 to 4 you'll need to write in words. The next one's using digits, and then you've got questions 9 and 10 to have a go at as well. You'll probably want to pause the video at this point so that the answers don't come up too quickly. So number 1, the answer is 304,762, then 76,035, 4,582,091, 80,607. Question 5 should look like this. 6 like this. 7 like this. Then 8. Then what is the value of the 3 in this number? The answer is 30,000. The 8 in the next number is 800,000. Then can you partition this number? It's made up of 9,000 plus 600 plus 20 plus 8. And then the following number is 30,000 plus 5,000 plus 400 plus 30 plus 1. So far we've looked at how place value can help us to read and write whole numbers. Now we're going to look at how place value can help us to write decimal digits. So again, we've got our place value scale here. We might be asked to write the number 3 hundredths in digits. So we put the 3 in our hundredths column and then placeholders in. So 3 hundredths is 0.03. 6 tenths. Put a 6 in our tenths column and a placeholder in, so 6 tenths is 0.6. 32 hundredths. 32 in our hundredths column and our placeholders in. But there's a problem here because we're not allowed to put 2 digits in one column. So if we want to write 32 hundredths, we have to do this. We leave the 2 in the hundredths column and the 30 moves across to the tenths column, and then we put our placeholder in. So 32 hundredths is 0.32. And this is explained in more detail on the next slide. 8 thousandths. We put an 8 in our thousandths column and our placeholders in. So 8 thousandths is 0.008. 95 thousandths. Again, we've got 2 digits in a column and we're not allowed to do this. So what we have to do is we leave the 5 in the thousandths column. We move the 90 across to the hundredths column and then put our placeholders in. So 95 thousandths is 0.095. And lastly, 114 thousandths. So I've put 114 in my thousandths column, my placeholders, but again we can see that we've got too many digits in one column. So if you have a question like this, this is what you do. You leave the last digit again in that column. The 10 goes across to the hundredths column and the 100 goes across to the tenths column. And then we put our placeholder in. So 0.114 actually reads as 114 thousandths. So now I'm going to try and explain how it is that we can move digits across to the left if we have too many in one column. So again, here we have part of the place value scale. And what I've done is I've represented one whole unit as this square. So if I take the same square and put it into my tenths column, it's divided equally into 10 pieces, and each of those pieces is 1/10, and we can see that 10 tenths is the same as the 1 unit. If we take the same square again and this time divide it up equally into 100 pieces, we can see that 100 hundredths is the same as 10 tenths, which is the same as 1 unit. Then if we put the same square into the thousandths column, each one of those tiny little squares is 1,000th, and there are 1,000 of them, so that 1,000 thousandths is the same as 100 hundredths, which is the same as 10 tenths, which is the same as 1 unit. Then if we look to the other side of the decimal point, to our whole numbers, we can see that if we had 10 of those units, I haven't shown them here, but imagine there are 10 of those, that would be the same as 1/10. Then 10 tens is the same as 100, and 10 hundredths is the same as 1,000, and so on. So this is the basis of our metric system. So if we look at some examples, imagine I was asked to write 12 tenths. Well, we can see that we've got 2 digits in the tenths column, which we know we're not allowed to have. So we take the left-hand digit and we move that across to the next column to the left, which happens to be our units column. So if you're asked to write tenths, actually you would have to write 1.2. And the reason for that is that we've got 12 of them. Well, we know that 10 of them is the same as 1 unit, so we can change the 10 of them into the 1 unit and then leave the other 2 in the tenths column. Look at another example. Here we've been asked to write 26 hundredths. Again, I've put 2 digits in 1 column, which we can't have. So we take the left-hand digit, the 2, we move it to the next column to the left, which is our tenths column. So 26 hundredths looks like 0.26. The reason being that 20 hundredths is the same as 2 tenths. Then looking at our last example, this is a whole number. Here we have 10. Again, I've got 2 digits in the same column, which I can't have. So I take the 1 and I move it to the next column to the left, which is my tens column. So 10, the way we write 10 is 1 in the tens column and a 0 in the units column. So now we're going to look at how place value can help us to read decimal digits. So we've been given this number 0.09. If we put that on the place value scale, we can see straight away that the 9 is in the hundredths column. So this number represents 9 hundredths. 0.8. The 8 is in the tenths column, so this represents 8 tenths. 0.004. We can see straight away that the 4 is in the thousandths column, so this number represents 4 thousandths. 0.59. We could say that this number represents 5 tenths and 9 hundredths, which is correct, but we've got 2 different names there and we want one name for the number. So this number represents 59 hundredths, because 50 hundredths is the same as 5 tenths if we think back to the slide that we've just looked at. 0.037, again we've got 2 digits here. We've got 3 hundredths and 7 thousandths. We need to change that into one name. This number represents 37 thousandths because 30 thousandths is the same as 3 hundredths. And the last one, 0.168. Here we've got 3 different names potentially. We could say its value is 1/10, 6 hundredths and 8 thousandths. We need to change that into one name. So this number actually represents 168 thousandths because we've moved the digits across. And there's a really handy little tip for reading these because they can be quite tricky. So where you have more than one decimal digit, read the column heading of the last one to find the name. So if we look at 0.59, we can see that the last digit is a 9 and that digit is in the hundredths column. So that's why we call it 59 hundredths. If we look at the next one, the last digit is a 7 and that's in the thousandths column. So that number reads as 37 thousandths. And the last number, the last digit is an 8 and again that's in the thousandths column. So we read that number as 168 thousandths. Now we're going to look at how place value can help us to partition decimal numbers. So we've got 0.38 here. What is that made up of? It's made up of 3 tenths and 8 hundredths. And again, this can be useful when we're doing calculations. This number is made up of 1/10, 6 hundredths and 5 thousandths. This one, 9 tenths and 7 thousandths. Notice we've got a placeholder in the hundredths column. We might also be asked to use partitioning to find out what is missing from numbers. So for example, 0.861 is made up of 8/10 and 1,000th and what else? So if we put it on the place value scale, we can see that the missing digit here is 6/100. It's about this one, 3.42 is made up of 3 units, 200ths and what else? So we put it on the place value scale, we can see that the missing digit is 4/10. Here we've got 57.094, which is made up of 5 tens, 7 units, 9 hundredths and something missing. So we put it on the place value scale, we can see straight away that it's the 4,000ths that's missing. Or we might be asked to say what we would need to add to a number to change it into a different number. If we look here, the difference between those is 12 hundredths, and that's what we would have to add to the first number to change it into the second number. And the last one, what would we need to subtract from the first number to make the second number? The answer is 5/10. You can see the difference between them is the 5/10. So here's another practice page for you, this time with decimal numbers if that's useful. So can you read and write the following numbers? Again, I've put the place value scale at the top of the page to help. The first 5 numbers need to be written as words, the next one's in digits, and then you've got questions 10, 11 and 12 to have a go at. You may again want to stop the video at this point so that the answers don't come up too quickly. So the answer to number 1 is 9/10, number 2, 38 hundredths, number 3, 6,000ths, number 4, 74 thousandths, and number 5, 205 thousandths. Number 6 looks like this, number 7, number 8, number 9, number 10, what is the value of the 4 in this number? The answer is 4 hundredths. The 5 in this number is 5/10. Can you partition 12.6? It's made up of a 10, a 2 and 6/10. And partitioning the next number is made up of a 700, a 40, a 3 and 100th. What would you need to add to the first number to make the second? The answer is 500ths. Thank you for watching, and I do hope you found this useful, and please do have a look at my other primary maths and SATs help videos.